Hi everyone, welcome to the class of Geometry and Algebra. From 8th standard, we learn geometry and algebra every year. We learn formula, theorems, and solve lots of numericals in each chapter. The curious question we always have is why I am learning this much of mathematics and especially the geometry and algebra. Today we are going to take some real world examples where geometry and algebra is used. Let's get started. What are the topics that we learn in geometry in school? First, very simple. Y equal to mx plus c. Yes, you guessed it correct. A line. Then, a circle, which is x square plus y square equal to r square. Then we also learn about ellipse, parabola, hyperbola, plane, hyperplane, hypersphere, and lot more. Our question is, why are we learning all these equations, algebra, and numericals? These things we need to remember forever. Whatever we learn about geometry in school days, most of them are revised in college also. But yes, in some advanced applications. Taking a heavy dose of mathematics in each standard, we have big question why? Why do we learn it? Where is it used? Is it even useful or not? Why to use formula? How to make use of geometry shapes and their respective formula? Why are we learning only 2D and 3D? Is there 4D, 8D, or even 100D? We use geometry everywhere from simple sun clock to fighter jets. Using algebra, we can write a formula or function of different geometry shapes. For example, the equation of line in 2D is ax plus by plus c equal to 0, or you can say y equal to mx plus c. Cool. And equation of plane, which is in 3D, is ax plus by plus cz plus d equal to 0, where x, y, z are nothing but my dimensions. We can draw a line or plane on paper or even on a computer screen. In 2D and 3D, we can visualize it. As a human, we can see only 2D or 3D objects. What about hyperplane in 4 dimensions? Right? What about hyperplane in, let's say, 10 dimensions? We cannot draw it or we cannot even see it. But we can write a formula using the algebra. That's the superpower of algebra. Now, let's take an example on how we can use the parabola in real life, or even simple line. Can we use it in the real life? Let's find out. Let's take an example for it. India won gold medals in javelin throw competition in Olympics and Paralympics as well in 2021. You would be surprised that geometry and algebra is used here to determine the maximum distance. Maximum distance is deciding factor in javelin throw competition. Here, we have our player throwing a javelin at some angle, which is called the angle of release. Height of release is not very important here. Let's try to answer some questions like what is the optimum angle of release so that the javelin travel as far as possible? And most importantly, how geometry in algebra is used here. At the end, we want to find out the relationship between the angle of release and the distance traveled by the javelin. Let's conduct an experiment where we ask our player to throw the javelin with full strength at different angles to find out the best angle of release. First, player throws the javelin in the horizontal direction, which is at 0 degree angle. The average distance we get with the angle of release at 0 degree is 10 meters. Now, player increased the angle of release to 15 degree. Now the distance also increased to 30 meters. In next turn, player throws the javelin with the angle of release at 30 degrees and again the distance increased. Interesting. So we can say that the distance is increasing with the increase in angle. They are directly proportional to each other. Is it really? Let's find out. At the angle of 45, we get the whooping 90 meters, which is really good to get the gold medal. Now, our enthusiast player thinks I will break the world record by throwing the javelin at the angle of 60 and get the 100 meters. Even after multiple tries, he got the average 60 meters only. So, then he tried with the angle of release at 75 and the distance decreased again to 30 meters only. When he threw it at 90-degree angle, which is vertical throw, javelin hit his head. Oh, I'm just kidding. Now, if we draw distance versus angle graph on the chart paper, we can say that We get the maximum distance when angle of release is 45 degree. You must have proven this in physics lecture in projectile motion using some sin theta, cos theta, blah blah blah. What did we observe in this experiment? Object in projectile motion follows parabolic path. Whatever we throw on Earth horizontally in upper direction follows parabolic trajectory. Also, the distance traveled by object and angle of release have the parabolic relationship. Distance increases up to 45-degree angle and then it starts decreasing, so it looks like a parabola. What is the use of this observation now? What are the use of all this experiment and getting this kind of relationship? Leveraging this relationship in algebra, we can calculate the distance using the equation of parabola. Let's take one more interesting example. In tank, we shoot the shell or bomb from the barrel. This barrel can move in left and right, also in up and down motion. The distance bomb will travel depends on the angle of the barrel. Using algebraic formula of parabola, we can determine the location of it and target the enemy's tank. Let's take one more example from Olympic game called shot put, where player has to throw a heavy ball at maximum distance it can go. Here also we need to throw the ball at 45 degrees, same as we saw in javelin throw to get the maximum distance. Let's take an interesting example of satellite launch using GSLV or PSLV launch vehicles, or sometimes it's called rockets. When the rocket is launched with the satellite, it follows the parabolic trajectory. Once it is in orbit, satellite is free from gravitational force of Earth. Then the satellite starts revolving in elliptical or circular motion around the Earth. Here, the equation of ellipse or circle can be used here to find out the speed or location of the satellite.